The videos for NS Conference 6 have been sponsored by Microsoft Azure. For more information, go to azure.microsoft.com/iOS.
Would you please put your hands together and welcome to the stage from Edinburgh, Marcos.
So I'm here today to talk about using sounds to understand code execution and code flow. I've titled Sound Debugging. So I tweeted this a couple of months ago. So for those who don't know, Xcode actually has the ability to play sounds on a breakpoint. So assuming you put a breakpoint on one line, you set the sound you want to hear, and then as soon as the breakpoint is hit, you hear the sound. Simple as that. And the idea is that you make this composition by putting sounds in your code, and then you come up with this pattern of sounds that you expect to hear, assuming everything goes as normal. And usually it starts with a sound sample. So you lay down the sounds, you create your sound sample, and you then listen. Listen. Did anyone hear that? Yeah? Okay, so that's money, right? So you hear the sound sample, and that's it. So let's hear it. Let's see some use cases. So in this case, we want to figure out whether a table view dequeues cells or not. So I'm pretty sure everyone's familiar with how a table view dequeues cells rather than creating a cell every time as you scroll past the scroll view. So the question is, does the table view dequeue cells or not? So that is the question that you ask yourselves. So where do you put the sound? You put it on the init of the cell. So assuming it gets created, you listen to this sound. Okay? So that's the sound of a new cell getting created. So you put that breakpoint there, and then what do? You listen. Okay? Our cell is being reused. Are cells being reused? Yes? No? No, right? Because you keep hearing these sounds like as cells are being created again and again as you scroll the scroll view. So how would it sound like if it was reusing? No sound, right? You heard it up first when it first loaded the cells. So it loaded all the cells there are to show in the table view. And then after that, as you scroll through the table view, you had no sound. So no new cells are getting created. So your dequeue works. That means your cell identifier was set, you've wired up your prototype cell correctly. It just works. Let's hear a different example. So let's look at this code. So this code dispatches a sound block, in a queue. Can you tell from the slide what queue that is? Whether it's a serial or whether it's concurrent? You cannot tell, right? So the question then is, what type of queue is it that I'm dispatching blocks to? So again, we create our composition of sounds. In this case, we're going to have 3 sounds, one for its block. Okay, so we have 3 blocks. We set breakpoints for its block, different sounds, and that's how they all sound. You hear that? Ding, ding. Okay, so 3 blocks executed. So we've set our breakpoints. This is the sound sample we want to hear. And let's listen now. So is that serial or concurrent? Concurrent? Yes? Heads up? Hands up? Concurrent? Serial? Concurrent, right? It's concurrent because you you heard that sound like playing beep, beep, tick, beep, beep, tick, and then it went like beep, tick, beep, tick, tick, beep, and then triggered again, right? So you knew nothing about this code. All you saw was that queue. You didn't know what queue it was, and just by the sound of it, you could tell whether that was a concurrent or a serial queue. And let's see how a serial would sound like. So the blocks, execute serially. You can't hear anything. And obviously you have to understand the limitations, right? In the sense that especially when you're dealing with threads, you have to listen to a couple of samples before you actually make a case, understand whether it's a serial or a concurrent queue. What about this code? Can you tell what this code does? It's hard, right? It has ground central dispatch, it uses AFN, maybe you're not familiar with the code. It's hard to read through that code and understand what it does. And the question is it a success, a failure, or a timeout? Okay, so once again, we put our sound breakpoints. So we'll put one when we create a new operation, we'll put one if it succeeds, we'll put another sound if it fails, and we put another sound breakpoint if it times out. Okay? So let's familiarize ourselves with this sound. So what does it sound like? So the sound of new, it's this. The sound of success, the sound of failure, and the sound of a timeout. Okay? So once again, we've decided on a sample, we set the breakpoints, and then we'll listen. That was a timeout. So you had the operation getting created at first, and then after a while, it timed out. So it turns out it's missing the call to the start. So we forgot to actually start the operation. That's why it timed out. So we put that call there, and let's listen again. Timed out again, right? Okay, so if you look closely, you see that actually the main thread is blocked as part of running that test. So we need to actually define our success and failure blocks in a concurrent queue so that it has time to execute those blocks and then assert. So let's listen again. It failed. Okay, and the reason it failed is because the Foursquare API requires authentication, actually. So it failed on the authentication. And again, you didn't know anything about this code, right? It was the first time you see it, and just by putting those breakpoints in key areas, you can understand how it flows and how it works. Again, know the limits. With every instrumentation, it affects the performance, so your program will run slowly as it tries to play those sounds, and that's mainly because sound block, it needs to finish the sound playing before it continues execution as well. So where else can sound help? So another things like code execution, like on gestures. Does the gesture register as I think it does? On object lifetimes, do objects leave more than expected? Are they deallocated properly? The timing, is the timing right? Timers, do timers invalidate notifications? Have you stopped listening? Are notifications firing correctly as you would expect? Have you registered properly? Animations, does the execution, does what I see on screen match the sound that I hear? Are all the frames there? On functional testing, maybe you can create sounds for what it means to post a photo on Instagram, for example, or to post on Facebook, or do some action. Or I'm curious about whether it's possible to have a sound wave for a function that can be used as a hash. So the idea is that you compose all these sounds on a function of your app, and then you create the sound wave, okay, going up and down, and then you create a hash from that sound wave, and then I'm wondering if that can be used to assert code paths and help with integration or functional testing, maybe, I'm not sure. On education, maybe, how do algorithms sound? What does binary search sound? So for example, you can think of, the tempo changing as it gets closer to the result, or when does a hash table resize, how frequently and how it all behaves, again, just by listening to sounds. And maybe understand the performance at a high level. I said that it affects performance of your code, but maybe it's helpful to understand at a high level, like does this code run fast? Does it run slow? Does it run as it expected? Just get a feeling, of the code. Obviously, you need better support in Xcode, so if you please go to bug report if you like this idea and file a bug report. I've already filed one. Basically, it's tedious right now because you need to set the breakpoint, you need to right-click, edit the sound, continue execution, and it's not intuitive. And I find that gets on my way every time I want to use sound debugging because I have to do all these steps every time, and it's difficult. Like I would have liked to press a keystroke here and there and it worked. And one more thing, last year at NSConf I talked about passwords, right? And not using passwords. So why aren't we password-free yet? Go read that post and come back. That's all. Thank you.
The videos for NS Conference 6 have been sponsored by Microsoft Azure. For more information, go to azure.microsoft.com/iOS.